My name is John Wu, a marketing engineer from Microchip's Mixed Signal and Linear Business Unit. Today, we'll be discussing the op-amp startup time. In this video, we'll discuss the difference between the selling time and slew rate versus startup or power-up time. Then we'll present a case study for measuring startup time. Let's say that we're looking at the output of an op-amp. At T1, a signal is applied, and you can see the overshoot of the output signal. After a certain time, the output signal falls within the tolerance threshold. At T2, the signal reaches the tolerance threshold, and the difference between T2 and T1 is the selling time. The slew rate is the slope of the output signal. The startup or power-up time is the time that the op-amp takes to reach steady state when the power supply is switched on. At T1, the power supply is turned on. You can see the output voltage here. The time when the output voltage reaches steady state is the startup time. Why do we care about startup time? Well, many battery power applications will put active circuit into sleep mode to conserve battery. For example, some system would simply disable the V supply on circuit blocks. So the faster a block can reach the steady state, the sooner the system can do its signal conditioning and data logging. Then the system can get back to sleep again to conserve battery. Here's a high-level schematic of measuring the startup time. The V supply, or VDD, is represented by 0 to 3 volt square pulse. When VDD is 0 volt, the op-amp is off, and the output impedance of the op-amp is high at this point. Since the op-amp output voltage is directly related to the low voltage, the expected value of Vout is at 1 volt. When we switched on the VDD, the square pulse is at 3 volt. The op-amp is turning on, and the output is becoming low impedance. At this point, the output becomes a function of the applied input voltage. The time at which the output follows the input sine wave is the op-amp startup time. Note that the 50 millivolt DC input is required to keep the output away from saturation into negative rail once the op-amp V supply is switched on. It should not help with the startup time of the device under test. Also, no bypass capacitor are used in the test circuit to minimize the inrush current. Based on the test circuit discussed previously, we measured the startup time of Microchip's new general purpose 1 megahertz family. That is the MCP 6006, 7, and 9 single, dual, and quad channel. The MCP 6006 product family has a startup time of 6 microseconds, which is nearly 10 times faster than the nearest competitor. At the same time, the MCP 6006 family maintains high output impedance during startup. We also compared the inrush current of the MCP 6006 and 7, 9 family versus competition. You can see that it also consumes very little inrush current during the startup, and it is nearly 40 times lower than the nearest competition. Finally, the new MCP 6476, 7, and 9, the 3 megahertz version of the 6006 family, has similar startup time performance. We'll post the product link in the video description. In this video, we discussed the startup time versus selling and slew rate. Then we follow up with a method of measuring the startup time. Having more information on the startup time, we hope it offers you more flexibility in your system design trade-off. Thank you.